Afternoon, kids.
Afternoon, sir.
How you doing?
We are fine, thanks. How are you, sir?
I'm all right. Today, we will look at the practical part of the capacitors. What you're looking at right now is a ceramic capacitor. It is used in high-frequency circuits for filtering and decoupling. Let's pick one and see. This one is written 104. That 104 gives the capacitance value of this capacitor. Let's calculate on this piece of paper and see how much is the value of this capacitor. Written 104. The first digit is just a number, the second one is just a number, and the third one is the multiplier or the number of zeros. So there are 4 zeros after this one. So it's going to be 1, 0, 1, 2, 3, 4. That gives us 100,000. 100,000 is equivalent to 100 nanofarad. Let's use this meter to confirm the value of this capacitor. It gave me 90.63 nanofarad. Yeah, this meter takes the tolerance into account. That's why you see 90.63 nanofarad. But on a calculator, we get 100 nanofarad. Let's take another one and see. This one is written 22 with the voltage rating of 400 volt. Let's see. The voltage rating is 100 volt, not 400 volt. It's 100 volt. Now let's see the capacitance of this capacitor. It's written 2. The first 2 is a digit, the second one is a digit, then there are 0 zeros since there's no third digit. So this one is a 22 picofarad. Let's see what the ceramic disc look like on the inside. I'll just draw a small sketch for demonstration purposes. This is the electrode. This is ceramic that separate the two electrodes. Now this wire that you see from the capacitor attaches on this electrode, and then on the other side there will be a wire again attached to another electrode. So if I draw it from the rear, it will look something like this. This is the ceramic that separates the two discs. Then these wires attach like this on this electrode. So this brown stuff that you see on the outside is just a protective coating. So this is a ceramic, hence this is called a ceramic disc capacitor. The ceramic, this is the electrode, and here it's just a wire. Now that's how your ceramic capacitor look like on the inside. So if you connect it on a circuit, probably connect this one from the signal source, and then this one will go to the next component or circuit. Unlike an electrolytic capacitor, this one is not polarized, so you can connect it anyhow, it won't explode. Now let's move over to the next capacitor, which is the electrode capacitor. This is the electrolytic capacitor. It is polarized, as you can see here on the side. This white stripe indicates that this leg or this wire is negative, and on this side it is positive. So when you connect it to a circuit, you must connect it with care, because if you connect it the wrong way around, the capacitor will explode. These capacitors basically they are used for power filtering, energy storage, and to block DC in power supplies and audio circuit. They have a lifespan, meaning after some time they might drop in their capacitance value or start to have a charge leakage. They're also sensitive to high temperature as compared to other capacitors. This capacitor, you don't have to calculate the value of the capacitance. They write it for you on the side here. This one is 2200 microfarad with a maximum voltage of 35 volt. Meaning if you exceed 35 volt, if you put it in a higher voltage circuit, it won't be able to handle that voltage, therefore it will explode. They even indicated the amount of temperature it can withstand, which is 85 degrees Celsius. Above that, it might start leaking, or it might start malfunctioning, or even explode. That's how it looks like. Let's check this one. This one is a 3300 microfarad with a maximum voltage of 16 volt. The temperature it can withstand is 85 degrees Celsius. Above that, it will malfunction or explode as well. They are all the same. Let me use my meter just to check one. Let me test this one. Here it gave me 9127 nanofarad, which is pretty much closer to 10 microfarad. With all that being said, let's have a look at how it looks like on the inside. This one is the one that you connected on the wrong way around and then it exploded. That's how the pins look on the inside. Actually, it's not the pins, these are the plates. That's how it looks on the inside. In a circuit, you'll see it like this. This is the symbol for electrolytic capacitor. It's either they will indicate by means of a positive and a negative to indicate the polarity of connection, or they'll do it like this, and then they shade the negative plate. So if you to connect a capacitor in the circuit, you'll have to connect it like this for it to work. If you connect it like this, it means that you connected it the wrong way around, therefore it will explode. Now let's move over to the next capacitor. This is a tantalum capacitor. Tantalum capacitor is basically an electrolytic capacitor with a high performance. It uses tantalum metal for its anode, tantalum oxide as the dielectric, and typically manganese dioxide or polymer as the cathode. It is much smaller than the usual electrolytic capacitor, which is this one, and it gives high performance. It is also polarized, just like the electrolytic capacitor. On this side, as you can see, it marked with positive here, meaning this is the positive part of the capacitor and this is the negative part of the capacitor. If you connect it the wrong way around, it will also explode. And this is the SMD part of the tantalum capacitor. This mark here indicates that this is the positive or simply an anode, and this part is the cathode. So it operates basically the same as the electrolytic capacitor. Let's move over to the next type of a capacitor. This is a film capacitor. Film capacitors are characterized by being very stable and accurate. Normally they are used in audio circuits, timing circuit, and signal coupling. Film capacitors are not polarized, meaning you can connect them anyhow, they won't explode. They also don't write the value of the capacitance, so they write digits so that you can calculate the value of the capacitance yourself. This one is written 205K with a voltage rating of 250 volts. Let's see the capacitance value of this capacitor. The rating 205K. The 2 is a digit, 0 is a digit, then we have the 5 number of zeros. 5 is the multiplier. 1, 2, 3, 4, 5 with picofarad. And then the K is the tolerance. K is plus minus 10%. This value is equivalent to 1, 2, 3, 4, 5, 6, 2 microfarad with plus minus 10% tolerance, or we can say is 2000 nanofarad with plus minus 10% tolerance. Let me use this machine to confirm this value. Says 2071 nanofarad. Then we got here 2000 nanofarad. So they added that plus minus 10% of tolerance. This one I can barely see here, but it's written 155J with a voltage rating of 400 volt. Let's see the capacitance value of this one. 1, 5J. 1 is a digit, 5 is a digit, then the other 5 is a multiplier. 1, 2, 3, 4, 5. And then J give us a tolerance value of plus minus 5%. Oh yeah, it's picofarad. 1, 2, 3, 4, 5, 6. This is equivalent to 1.5 microfarad with a plus minus 5% tolerance. Is also equivalent to 1500 nanofarad with a plus minus 5% tolerance. Let's confirm this value. It's 1193 nanofarad. It is pretty close. So they minus the 5% tolerance. Now with all that being said, let's move to the next capacitor. This is a mica capacitor. It uses a thin sheet of mica as a dielectric, which offers a very high precision and stability and also a low loss. These capacitors are widely used in high frequencies, radio frequencies, and high voltage applications, just like filters and timing circuit. They are also widely used in transmitters, more especially these modern silver mica. They are very good in handling high frequency. And the capacitance value of 220 microfarad with a tolerance of plus minus 5%. They are also not polarized, so you can connect them anyhow. Now with all that being said, let's move over to the next capacitor. Now this is a variable capacitor. Variable capacitor have a minimum and a maximum value, but you can tune the capacitor between the minimum and the maximum value to select the value that you want. Hence it is called a variable capacitor. These capacitors normally they have a dielectric just like this one, for high power circuits, and ceramic or plastic trimmers for fine tuning. Normally these capacitors are used in RF circuits, oscillators, and antenna tuning, but you'll also find them for impedance matching and also in the radios. To adjust the capacitor, you can adjust it mechanically. These small ones, you use the screwdriver to adjust it to the particular value that you are looking for. But this DIY one, I will adjust it myself using my hand. So let's see how this capacitor works. Now at the moment, the value of the capacitor is 0.011 nanofarad. Let's see what will happen as I adjust the top plate. You see the value changes. And as the top plate goes to the top, the value of the capacitor decreases. Now let's conclude the topic for capacitors.